Hello everyone, we are Jak&Jonas. We are a rescue maze team from the Student Research Center in southern Germany. Our team consists of just the two of us, Jonas and Jakob. We founded our team back in 2019 as part of our school's robotics club. We've been classmates for years, and our shared passion for robotics brought us together. From the very beginning, we were fascinated by the rescue leagues, because we loved the idea of solving real-life rescue scenarios, even if only in simulation. In 2019, we started out in rescue line entry, but after being apart during COVID, we reunited in 2022. And this time, we decided to take on a new challenge, Rescue Maze. Since then, we've spent countless hours designing, testing, improving, iterating on hardware, refining our code, all with one big goal: to qualify for the Robocup Junior World Championship here in Brazil. Over the years, we've gotten closer and closer to that dream. 2019, we didn't even make it to the German nationals, but since then, we've kept pushing. We competed in the European Championship, first in Maze Entry in 2023, then in Maze Proper last year, where we even took third place. Along the way, we naturally found our roles. Jonas focused on hardware, designing 3D printed parts, building custom PCBs tailored to a robot's needs, and even training a neural network to detect victims using our camera system. Meanwhile, Jakob handled the integration, bringing together all the sensors and microcontrollers into one unified system. He also developed the robot's mapping and pathfinding, so the robot can build a map of the maze and figure out the best way through it. Together, we built this robot. It has a few special features. Let's start with the moving axis. It can tilt up to 45 degrees in both directions, allowing the robot to climb over large obstacles, like this one. It's from 2024, but back then our robot looked very different, but the axis design, it stayed the same. Now let's talk about the wheels. We designed 3D printed custom molds, filled them with liquid silicon, and then let them solidify. The result: high quality wheels with excellent grip on almost any surface. To move through the maze, the robot uses time-of-flight sensors. Each one is connected to a custom-made circuit board, ensuring a stable and safe power supply. These sensors help the robot measure distances to the walls accurately and in real time. To detect colored or black tiles, we added a color sensor and a brightness sensor to the bottom of the bot. And now, one of our most innovative features, the drop-off system. There's a sliding mechanism on both sides and a servo in the middle that decides where the drop-off kit goes. This lets us place the kit as close to the wall and as close to the victim as possible. I think that's enough talk about the robot. Let's see it in action. It starts driving, and right away it detects a letter, an H, which marks a victim. The rescue kits, as shown earlier, are dropped very close to the victim. In the bottom right corner, you can follow the map that the robot builds on its own as it explores the maze. It keeps track of tile colors, victims on the walls, and of course, the walls themselves. At first, the robot follows the right-hand rule, continuing along the wall until it reaches a tile where the next tile it would drive onto has already been visited, like here. At that point, it starts searching for the fastest way to the next unexplored tile. To do that, it uses the flood fill algorithm to find a valid target. Once it reaches that tile, it calculates the shortest return path back from there, and then follows that exact path forward. From now on, the robot switches to pathfinding mode. It ignores other options and follows the pre-calculated path until it reaches the target tile. Then it goes back to using the right-hand algorithm to continue exploring. One of the most challenging parts of this robot was getting it to drive exactly one tile at a time. Even though it sometimes looks like it's moving over multiple tiles without stopping, it actually checks its progress after each individual tile. After each step, it decides whether to turn right, keep going straight, or switch back into pathfinding. To precisely detect these lengths of the tiles, it uses mainly encoder values, but also distance sensors, since they are simply more accurate. Now the robot has reached the final unexplored tile and needs to return to the start. Once again, the flood fill algorithm is used, this time from the target back to the start. The return path is calculated and followed step by step. On its way back, it detects another letter, a U. The robot scans for letters both while driving and while turning, like here, because sometimes it misses one the first time around, so we added an extra check. Now it turns back into its starting orientation, does a final check to make sure everything was covered, and then performs the exit bonus. This year will sadly be our last time competing in the Robocup Junior. That's because both of us will be heading to university next year. But that doesn't mean that our Robocup Junior ends here. We'd love to stay connected, perhaps as mentors for new teams, or maybe even by joining the Robocup Major League, taking things to the next level. But for now, our focus is right here, on this World Championship. We want to make the most of it, give it our all, and achieve the best results possible. Most of all, our goal is to gather new experiences, learn from other teams, and, above everything, have fun and enjoy Brazil.